Lesson 4.4 is graphs of, as I said, sine and cosine. Now, the first thing I've provided here is just a basic graph of what sine looks like and what cosine looks like. Okay, so sine, now, this is just what I would call one cycle of sine. Okay, if you graph sine on your calculator, it actually goes on and on forever. Okay, so one cycle of sine starts at 0 and ends at 2 pi. So it has a length of 2 pi. And what it does is it starts at 0, a quarter of the way through, so pi over 2. It has a max at 1. Half the way through at pi, it cuts through the x-axis, so it has a 0. 3/4 of the way through at 3 pi over 2, it has a minimum at -1. And then at the end of the cycle at 2 pi, it cuts back through. Okay, so that's just the idea of what a cycle of sine looks like. Again, it doesn't end right there at 0 and 2 pi. It keeps going on forever. Okay, it goes on up and down. It's what we call an oscillating graph. Now, cosine is technically the same curve. It's just shifted over. Okay, so cosine also has a cycle that we're going to talk about from 0 to 2 pi. At 0, it has a max at 1, so it starts high. Quarter of the way through, it cuts through pi over 2. Halfway through, it has a minimum of -1 at pi. 3/4 of the way through, so at 3 pi over 2, has a 0 again. And then at 2 pi, it maxes out. Okay, it has a max at 1. And again, it keeps going and going and going. You grab your calculator real quick and just, take a peek at this. Okay. If you just graph sine x. Has it been a moment since we've graphed? Now, this is just, I did a regular 10 by 10 screen. Some of your graphs are looking like mine, some of them are not. If your graph is not looking like mine, what you need to realize is that when we are working with trig functions, unless you have a reason to be in degrees, trig functions need to be dealt with in radians. So notice my calculator is in radian mode. When we graph these, you're going to need to be in radian mode to graph them. Now, does your calculator look like mine? Or your graph look like mine? Okay. Now, there is, on my Zoom list, I like to use Zoom 6, which is the Z square, or Z standard, excuse me. Number 7, Z trig. I like number 7 also, because it kind of zooms it in, and it makes it so that it counts by increments of pi over 2. Okay, at least going left and right, it counts by increments of pi over 2. So like right here, we're now seeing more of the sine graph. Okay, now, the other one we had was cosine, yes? I'm going to take sine off for a moment. Notice, does cosine look kind of similar, yes? It's just that up and down graph. It oscillates up and down.
It just hits pi over 2 and 3 pi over 2 instead of pi and 2 pi.
If you graph these at the same time, notice they are essentially the same graph, aren't they? They're just shifted over, okay? It's a phase shift over. It's translated over. It's just scooted over. But they are essentially the same graph. They just hit different locations. Okay. Now, I show you the calculator just because I want you to kind of see what sine and cosine look like. But to be honest, what we're graphing is not about how to use a calculator. It's about how to graph these by hand. Okay, so that's really what we're going to focus on. You can occasionally use the calculator to an extent to check yourself, but it's really going to be about how to graph these by hand. And so, if you notice right down here, we have the sine and cosine functions, okay? And the fancy way written out, y equals a times sine of bx minus c plus d. And your a, b, c, and d there represent different things being done to the graph, okay? For example, the number out front, your a. Think back to Algebra 2. Think back to what we did first semester pre-calc. What's a number multiplying out front due to a graph? We go back to Algebra 2, a number multiplying out front is going to, it's going to stretch it, or do we use compress or shrink? We've used both, I guess, haven't we? Okay, so now, you'll notice here it talks about A. So when we talk about sine and cosine, it uses the vocabulary word amplitude. Okay, and it's how far above and below the center line to count. What you guys would recognize this as is your vertical stretch or shrink. Okay, that's what it would have been in the past. This is your vertical stretch or shrink. How much is it stretching up your curves, your maxes and your mins, okay? Or how much is it shrinking it down, okay? So the absolute value of A, so that was just the positive version of A, is your amplitude. Or it's basically your stretch. It's going to stretch it, okay? One of the things we're going to talk about is finding the length of the period, okay? A typical period is just 0 to 2 pi. That's how long it takes us to complete one curve. Now, that's going to change sometimes. 2 pi over b, where b is your coefficient of x, that's going to be the length of one cycle. Now, the idea is one cycle is normally 2 pi. It could be longer. It could be shorter. This is essentially your horizontal stretch. Okay, this is your horizontal stretch or shrink, because it's going to change how long it takes me to draw a cycle of sine. Okay? C over B, which is the value added or subtracted in the parentheses divided by the coefficient of x, is your phase shift. This is, when I talk phase shift, this is going to shift me left or right. There we go, left or right. Get my left and right with you guys. But it's going to phase shift. And so that's like our translations. Okay, our horizontal translations is what that's like in the past. Okay. D. Okay, guys. C in the parentheses tells me how far we go left or right, opposite the sign. D is outside the parentheses. What's a number added or subtracted outside the parentheses do? It tells me how far we're going to go up or down. Okay, it's your vertical translation. Now, in this case, it's going to be the center line, because rather than try and move our graph way up, we're just going to relabel our center line is what we're going to do, okay? But this is your vertical translation. And lastly, if A is negative, what's a negative out front of a graph do? Out front of an equation do? It's going to take the graph and it's going to flip it. It's going to be your reflection. So a negative A means to flip the graph, or going back to algebra, it is a reflection. Okay? So, those are the pieces we're looking at, folks. I'm going to keep going back to this, and I'm going to refer to these pieces each time as we identify what happens with our graph, as we set up our graph, and as we sketch it. Okay? So you'll want to keep referring to this chart. With enough practice, you'll have this chart memorized. Okay? You'll know what each piece does. Okay, let's look at the first example here. First example is keeping it very basic, okay? Y equals 3 sine of x minus 4. First thing I want to talk about. I'm trying to decide what order I want to go in. And I know it's not in the order of the page there, but let's talk about the center line. Just because it's going to be the first thing I label when I go to do the graph. Okay, I like to write out everything here so I have it. What is my center line on this example? According to the chart up above, center line is represented by D. D is the number added or subtracted outside the parentheses. So D is -4. So I'm going to have a center line of -4. What it really means is this graph moves down 4, but I don't want to have to move down 4 in one of these graphs and then try and draw the graph. Okay, so we're going to rename the center line here a little bit. The next thing I like to talk about is the amplitude. According to our chart, what's the amplitude? Amplitude is represented by the absolute value of A. So basically it's the A value. What's my A value here?
3.
A is the 3 out front, yes? Okay, so my amplitude is 3. That's basically going to be how high and low does my graph go. Okay, and again, we're going to label this here in a moment and it'll make sense. Okay, we've talked about center line, amplitude. Let's talk about the period. I need to talk about how long is one cycle. Now, if you go up top, it says period. Length of one cycle of one cycle of sine or cosine, because that's what you are expected to draw is one cycle. Period is what? 2 pi divided by b. What is b? Where is b? Let me ask that.
Before the x, it'll be 1.
It's before the x, so it's invisible 1. So b is 1 in this case. What is 2 pi divided by 1? 2 pi. Keeping it easy on this first one. So that is your basic one cycle, okay, of sine is going to take 2 pi. Now, what about a phase shift? What'd you say?
Nothing.
Okay. A phase shift is supposed to be C over B, but C is supposed to be the number added or subtracted in the parentheses. Do I have anything added or subtracted in the parentheses?
No.
No, that means C is 0. That means you have a phase shift of 0. That means this graph does not move left or right. So we get to ignore phase shift on this one. Okay? And then the other thing I like to talk about, because sometimes we'll be graphing sine, sometimes we'll be graphing cosine. What are we graphing in this particular problem? We're graphing sine. Now, if you jump back up, and I know you don't have this memorized yet, but what's a sine curve look like? And how I like to say it is a sine curve is a hill and a valley. Fair enough? And I just kind of put that visual there because here's one of the mistakes you're going to make. It says sine, and you're going to draw cosine, or vice versa. So this is just kind of a mental question you have to make sure you ask yourself. Okay? Now, I'm ready to start labeling. In a normal scenario, what is the x-axis? The x-axis normally, don't write this down, has a value of 0, yes? But what's my graph doing here? The negative 4 means my graph is going to move down 4. Well, instead of trying to go down 4 and then draw the graph, what we traditionally do is we rename the center line. So this center line is going to be negative 4. You can name it right there, or you can put it right there at the origin. Okay, you have to have it there somewhere if you want the point. Okay. Now, okay, so you can put negative 4 here or here, whichever one makes you happier, or put it both. Now, the traditional sine curve, if you go back up to the top, each hill goes up, has a height of 1. Each valley has, I don't know what word I want to use there, the opposite of height of 1. Okay, so each hill goes up 1, each valley goes down 1, right? Now, amplitude can change that because amplitude is going to stretch it. How high is each hill going to go up and how low is each valley going to go now?
3.
It's going to go up 3. Now, what is up 3 from negative 4? That would be a negative 1, yes? So you at least have to have a negative 1 labeled there. Do you have to label the negative 3 and negative 2? No. Do you even have to technically put the tick marks? Not necessarily. But you have to have negative 1 labeled. And then, what would down 3 from negative 4 be?
-7.
Negative 7. So my sine curve is going to go as high as negative 1 and as low as negative 7. Are you with me? Okay. Next thing I'm going to talk about is a period of 2 pi. I only ask you to draw one cycle of sine and cosine. So one cycle of sine curve goes from 0 to 2 pi. And that's also the cycle they gave here, yes? So what I have you do is I have you take your x-axis and we're going to label it for 2 pi. Now, basically, since my period is 2 pi, I'm going to put a tick mark towards the right end, and that's going to be 2 pi. I suggest that you divide this into 4 pieces, okay? Because that's how it's easiest for me to teach that sine and cosine break into 4 pieces. Now, if I break this into 4 pieces, what's going to be halfway in between 0 and 2 pi? Halfway in between 0 and 2 pi is, don't make this hard, 1 pi, right? You guys are way overthinking this. Or scared to answer one of the two. Okay, so right now I have my cycle from 0 to 2 pi broken into 2 pieces. I asked for 4 pieces. So now let's take each of those halves and break it into quarters, yes? What's halfway in between 0 and 1 pi? You could say 1/2 pi, or more traditionally said is pi over 2. What's in between 1 pi and 2 pi? Okay. You can say in between 1 and 2 is 1.5, but what is 1.5 as a fraction? That is 3/2, or 3 pi over 2. This is going to be the hardest part for some of you, is labeling the x-axis. when we have to start mixing things up, because we have to think fractions. Okay, guys, I'm ready to draw my graph. Okay, I have everything I need. I'm going to kind of put some marks, and then I'll connect my dots. I'm drawing a sine curve, yes? A sine curve begins at the origin, yes? Then, a quarter of the way through, it has a max. So I'm going to have a max up there. Then, halfway through, it cuts through the x-axis. Then, 3/4 of the way through, it has a minimum. And then at the end, it cuts through the x-axis again. We're going to connect those into a nice, neat, flowing curve. Now, did you guys, my max is up at -1. Do you have it level with -1? My min is at -7. Do you have it level with -7? And then what I'm going to do is I'm going to draw a curve that looks like this. I do tend to put arrows on the ends because it does keep going. We're just not going with it. Now, this is where artistic ability becomes interesting. I'm going for, did you give a good attempt here, okay? Now, technically, they're not pointy, are they? Okay, they are rounded, so please try to work to make them rounded. Try to hit those points because that's things I'll be grading on. Now, this is where the calculator becomes only somewhat helpful as a check. We just graphed 3 sine x in parentheses -4. Well, if I graph that, right there, it's down off the graph, isn't it? And I'm in that Z trig window. What you can do if you want to see did it make sense is you can go into your window, x min. We just graphed over to 0, yes. X max, we went as far right as 2 pi, so you can put 2 pi in there. I don't worry about the x scale. Y min, how low did mine go? -7. Y max, how high did mine go? -1. Now if I hit graph, that matches up, doesn't it? So that's I mean, it's not an easy check thing to do, but it's kind of a thing that, okay, you can see that that fit in the window like I think it did. Okay, so really it's not much of a calculator thing, but I'm trying to give you some options. Okay, questions I need to answer on this one? Ready to try the next one? Okay. Next one, we're going to talk y equals -2 cosine of 2x plus 1. I'm going to go in that same order I went in last time. Center line. What is my center line? It's 1 because it's the d value, right? Add or subtracted at the end outside the parentheses. So center line is 1. Now I want to talk amplitude. What's my amplitude?
2.
It's your stretch out front, and I'm only going to use +2. Okay? It's amplitude of 2, so that 2 is, keep in mind how high or low my graph goes, if you need that reminder. Why didn't I use the negative?
Absolute value.
Okay? Officially, amplitude is absolute value of A, and so the amplitude is just 2. What does that negative mean? A negative out front
Reflected.
means we're going to flip this graph. We're going to reflect this graph. So there's going to be, because there's a negative out front, there's going to be a reflection. And it's always a reflection across the x-axis when the graph is out front. Okay? Okay? Okay, let's talk period. The period of a sine or cosine curve is normally 2 pi. Officially, we have to do 2 pi divided by b. Do we have a b value? B is your coefficient here of x. So for my period, I'm going to do 2 pi divided by 2. What is 2 pi divided by 2? 1 pi. So my graph that normally goes from 0 to 2 pi is now just going to go from 0 to pi. Okay? So one cycle of the curve is going to fit in pi, between 0 and pi. Phase shift is the other piece. Phase shift is C over B. What is C? I still don't have a number added or subtracted here, do I? We'll probably start that on the back. So there's no C, which means there's no phase shift. Okay, I'm trying to get you guys to master a little bit of the basics before we start doing phase shift. Okay. The only other thing we haven't talked about, what kind of curve is this? This is not a sine curve, this is a cosine curve. Sine curve is a hill and a valley, or however you want to describe it. A cosine curve is really just one big valley, isn't it? If you look up top, it's one big valley. However, what am I going to do with this one big valley? I'm gonna fit it on the pi, but I have a reflection. So my graph that does start high, go low, and end up high, now it's going to flip. And so instead of being one big valley, it's going to be one big hill or mountain. Okay? Those are the visuals I need you thinking. Ready to try this? Okay, center line. Label your center line as 1, because basically this graph is moving up 1. Either label the 1 out here or down or there at the center. I just need to see a 1 somewhere in there. Amplitude of 2 means what? How high and low you go. So from 1, you're going to go up 2 and down 2. What is up 2 from 1?
3.
And what is down 2 from 1?
-1.
-1. You guys may laugh, but some of you will miss points because you goof those numbers up. So, okay. Our period. Last time I labeled out 2 pi because I was doing one cycle. This time, what is one cycle? We just have to label out to pi. Now, you can use as much or as little of this x-axis as you want. Okay? It all comes down to how you label it. I can have someone that only uses half of this x-axis, and I can have someone that uses the whole x-axis, and you can both get it perfectly right depending on your labels. Okay? So it's all about labeling. Here's the deal. My period is pi. Wherever you want to put it, what I know, and I'm going to put it in the middle. What I know is that's as far as my graph goes. Okay, and I'm just doing this to kind of show you how it shrinks a little bit. Now, like sine, cosine, I like to break it up into 4 pieces. So from 0 to pi, I want it broken into 4 pieces. I'm going to start with a middle mark. What's the halfway point of 0 and pi? 1/2 pi, which is pi over 2. So now I've broken my period into 2 pieces. I asked for 4, so you've at least got to put some midpoints there. Okay? You don't always have to label them. I'm going to because we're still practicing here. What's going to be in between 0 and pi over 2?
Pi over 4.
Pi over 4. And if the pi's are throwing you off, just ask yourself, what's in between 0 and 1/2? 1/4, yes? So pi over 4. What's in between pi over 2 and pi? So what's in between 1/2 and 1?
3 pi over 4.
3/4, so 3 pi over 4. And if you got those all as common denominators, you could count, right? 1/4, 2/4, 3/4, 4/4. Okay. Are you ready? What am I graphing? Cosine, but reflective. So now, normally I would say cosine is going to start up here at 3. But, what's the but? It's reflected, so instead of starting up here at 3, it's going to start down here at -1. Now, each quarter mark, you're either always crossing the x-axis or you're hitting a high or a low. So right here, we start at -1. At pi over 4, I'm going to cross the x-axis. At the midpoint, pi over 2, I'm going to have a max that is at a height of 3. What do you think we're going to do at 3 pi over 4? You're going to cross. And what are we going to do at pi? You're going to have a minimum that is at the level of -1. Okay. And, maybe you're talented enough to just draw the curve all at once. For me, it's easier if I make some marks and then kind of play connect the dots. Okay. Now, I will say, when you get to the ends, realize those are mins. The graph is going to turn and keep going up. Don't make it keep going down. That could get you in trouble and cost you a point. Okay? And again, if you wanted to graph this, you could type this graph in. You could change your settings and see how it looks. Okay. Let's at least, I don't know where we'll end up on time, let's at least talk through the pieces for the next one. We may not get to actually draw it, I don't know, but are we starting to catch on a little bit? Maybe? Because guess what? We're getting ready to throw a phase shift in now. So, now that you know, you're starting to get a little comfortable. Can't let you get too comfortable. Okay. Can we speed up this process? I'm going to start with center line. What's the center line? 0, because it's the plus d value, which is a number add or subtract at the end. I don't have a number add or subtract at the end, so this graph doesn't move up or down. Center line is 0. Amplitude. How far am I going to stretch this up and down?
1.
It's the number in front of sine or cosine, which is an invisible 1 here. So amplitude is 1. So we talk about how high and low our graph is going to go. Just going to go 1. And no reflection this time, right? That's usually when I talk reflection. Period. The normal period for sine and cosine is 2 pi, and it's 2 pi divided by b. What's b? 3. So, one cycle of this curve is going to be the length of 2 pi over 3. So from 0 to 2 pi over 3 is going to be the length of this cycle. Phase shift. Phase shift officially is C over B. We actually have a C value, don't we? C is your piece that is added or subtracted in the parentheses, right? Now, what's C over B going to be here? Except it's going to be positive pi over 3. Here's the deal, guys. If you go back and you look at the original setup there, the equation is bx minus c. When the initial equation is minus c, that says you're going to use the opposite sign. Okay? So, because it's a minus pi, it's going to be a pi over 3, and this is positive, which means we're going to shift to the right. Here's the other thing you can do. You can also take what's in parentheses there and set it equal to 0. And this is so if you get confused on your signs. You take 3x minus pi and set equal to 0. Add pi over. So I have 3x equals pi. Divide by 3, and I have x equals pi over 3. I'm not saying you have to do that, but that's kind of a way to help you keep straight. So it's just like that whole idea of, what if I always talk? Left or right, opposite the sign. It's the piece in parentheses, it's left to right, opposite the sign. So this is going to be a right pi over 3. Okay. Probably a good place to stop. Okay. So, we'll pick up here tomorrow. We will draw this. We will very probably go over the other 3 examples, and then any other time will be work time. Okay? If you know you're not going to be here, I would encourage you to grab the worksheet ahead of time.